Hey everybody, I'm Shashank at AWS, and in this video we'll take a look at Amazon SageMaker Training Compiler. SageMaker Training Compiler is an optimizing compiler. What that means is it'll take a look at your model's computational graph and look for opportunities to improve training performance. It'll also make better use of GPU memory, thereby leading to a performance increase in your training by up to 40%. In this video, we'll take a look at what it is, how it works, what are some of the things it does, such as graph optimizations, operator fusions, and better memory management on your GPU to speed up training. And then we'll take a look at a code example where we'll go step by step and talk about what are the code changes you need to make in order to speed up your training. You don't need to make any changes to your training script. All you have to do is add a single line of code in your SageMaker estimator function and you can experience speedups. Let's start by talking about the optimizations that the training compiler does. So let's jump right in. Let's say you have a machine learning model, and this model comprises of different layers, and each of these layers include operations such as convolution, bias, ReLU, and so on. Now when the deep learning framework executes your computational graph, essentially what it would do is, in order to do convolution, it would make a function call to the GPU kernel implementation, get back results, and then bias, the same thing. It would call a GPU primitive to calculate the bias, return results, and ReLU, the same thing. It would call a kernel on the GPU and get back results. Now each time you call a GPU primitive, there's a function called overhead. So this can add up when you have tens or hundreds of layers in your deep learning training model. So there's an opportunity for improving performance here. So let's take a look at what an optimizing compiler can do to improve performance. Now this is your graph on the left. Now consider that each of these convolution, bias, ReLU blocks can be bundled into a single function call. So essentially what this would allow an optimizing compiler to do is take a look at opportunities like this and combine it into a single function call, CBR, which is convolution, bias, ReLU. So you go from all these many different operators into fused operators. This is called operator fusion, and you end up with a single kernel call to the GPU rather than the multiple kernel calls that you were making in the past. Okay? And you can also eliminate layers. A good optimizing compiler can eliminate layers such as this concat layer here by taking the results of a layer and writing them into GPU memory in a strided fashion this way. So essentially, rather than performing another operation such as concatenation, it can just write this into GPU memory in a strided fashion so that the result is the same as what you would do from a concat operation. There are many other optimizations that a compiler can do. An optimizing compiler such as SageMaker Training Compiler, because it has a view of the entire computational graph, so it can plan memory use ahead of time. So it can make better utilization of the GPU memory, resulting in far less memory utilization on the GPU, but also far less computation that it has to perform, thereby giving you opportunities to speed up training and increase batch size, which we'll take a closer look at in a demo. Now let's take a look at how this would work for you as a user. Now you as a user, if you're used to using SageMaker, you know that there are really two steps that you need to do. First, you need to write your training script, and you would do this anyway. If you were running deep learning training, you need a training script. So you would author this, and then you would also author the SageMaker SDK estimator function, and this is the function where you would specify that what kind of instance you want to train it, CPU, GPU, how many you need, 1 or 8 or whatever it is, what kind of framework version you want to use, and so on. You would specify this here. To use this function, you would add another option here in the SageMaker Training Compiler called Training Compiler Config, and you would introduce this into the estimator function. That is the only code change you need to make. You don't need to update your training script. You just need to specify the Training Compiler Config into your estimator function, and we'll take a look at this in the code demo. Now let's take a look at what happens behind the scenes. Okay, so you've prepared your training script, which you would normally do if you're training a model, and you added the line of code, which is the training compiler configuration, into your SageMaker estimator function. Behind the scenes, SageMaker will read the function and pull the AWS training compiler container. This is a special container that has the optimizing compiler, and it'll pull this from ECR and download your training script into the container, and then the container is downloaded onto the instance you specify. Let's say it's a GPU instance, P3, and when the training is initiated, the optimizing compiler will compile your training model, which will take, there is a compilation overhead, but the time that is consumed can be recovered because the training time is actually much shorter because of the optimizations that it does, and you get all the other benefits of SageMaker, which is dataset is downloaded from S3 and the models can be saved back to S3. Now let's jump into a code example and see how this works. Okay, what I have here is a Jupyter notebook that's running on SageMaker Studio. You of course could run this anywhere else you want, as long as you have your SageMaker SDK and the Boto 3 SDK installed. We'll go through this example in SageMaker Studio, and I'll make the code available to you so you can replicate it. So let's start by loading some of the basic packages such as Boto 3, SageMaker. We'll also get access to the default bucket because this is where we'll store the dataset but also save your model performance. Okay, and then we'll go through the process of downloading the dataset, and the dataset is an example dataset that's made available to you. If you want to replicate this example, let's go ahead and download this dataset, and let's take a look at what this dataset looks like. Okay, first, this dataset is free-form natural language text with a label 0 and 1, but the way dataset is, they're all mishmashed into a single row. So we'll do some pre-processing here in order to separate out the label column here and the natural language text problem. So essentially this is a binary classification problem. Okay, you want to predict the label based on natural language text here, and we have this data set available. And to do this, we'll be using the Hugging Face library, which is the framework that is supported currently for SageMaker Training Compiler as of today. There's a list of models supported, and I will show this to you shortly. So let's download this dataset, prepare this dataset, convert it into a dataset format that Hugging Face can process, and then we'll tokenize this dataset. So if you're used to working with natural language problems, you know that you have to go through the tokenization process, and each pre-trained model, in this case we're using BERT, has its own tokenizer. So we are going to tokenize the dataset, and after that what we will do is upload the dataset to Amazon S3. This is because when you run a SageMaker training job, it expects the dataset to be in S3, it'll download the dataset and then initiate the training. Okay, so there are a number of different ways to upload the dataset to S3. You can use the CLI, you can use the SageMaker Python SDK, or you can use the S3 file system API here in the datasets package. Totally up to you, as long as you make the dataset available in Amazon S3. Next, we'll take a look at how you'll run a training job with SageMaker. We haven't yet started the compilation training compiler part of this demo. This is your vanilla SageMaker workflow. So what we do initially is specify hyperparameters that you would use in your training script, such as epochs, batch size, and in this case model type is also a hyperparameter, but that's up to you how you define your training script. Okay, let's go ahead and run this, and as we discussed, the next step of course is to write an estimator function in SageMaker, and the estimator function is where you specify or tell SageMaker that you have a training script, you want to run it on a GPU instance. This is a P3.2x large, which is an NVIDIA V100 GPU. How many instances you need, what version of Python, what version of Hugging Face transformers, and so on. Okay, you specify all of this, and let's take a look at the training script. Now, this is your vanilla Hugging Face training script. If you're used to using Hugging Face, there's nothing special here. The only minor changes you would do in order to use it with SageMaker is to enable your training script to accept hyperparameters. This is just so that you have the flexibility to pass in different hyperparameters and run new training jobs, such as, let's say you wanted to do with 1 epoch and then 5 epoch and 10 epochs. You just pass this as a hyperparameter rather than rewriting your training script. Okay. Rest of the training script is your Hugging Face training script. You specify your training arguments, and you specify your trainer, and then you do trainer.train. Okay, nothing special here. This is your vanilla training script. Let's go back to our notebook, and then we can initiate the training by running this cell. Okay, I don't want to, this training takes a little while. I don't want to wait for this training to complete. So what you can do is, in the fit function here, when you specify the estimator.fixed function, you can specify wait equal to false, which means it won't be blocking. You don't have to wait for this cell to complete. The training is running in the background. If you want to check progress, you can always go to the SageMaker console here and click on dashboard, and you can take a look at the training in progress, or you can directly go to the training jobs here. You'll see I have a training job in progress. Okay, this is a training job I just initiated. Now let's go back to a Jupyter lab, and then what we'll do now is run the same training job with the compiler setting switched on. Okay, so we want to compare a training that is without the optimizations with the compiler optimized training. As you'll see, the only change I make to the hyperparameters is I've increased the batch size to 24. Previously my batch size was 14. Okay, now why did I do that? Why did I increase the batch size to 24? If you recall from our theory in the beginning, when you perform graph optimizations and better memory management, which is done by the training compiler, you have more memory left in the GPU, which you can use to store a larger batch size. Now, not only are you getting speed ups with the graph optimizations, you're also getting speed ups by increasing the batch size that you can store on the GPU during the training process. Okay, so there are a number of factors that can help you increase training performance when using the compiler. And if you ask me why 24, why not 26, it's largely trial and error. As a rule of thumb, you want to fit the largest batch that your GPU will allow. Now the P3.2X large is a 16 GB GPU, and you want to be able to fit the largest batch size available, so you can try up to the size that it can fit. If I could fit 30, I would fit 30, as simple as that. So let's go ahead and run the optimization part of the training with the optimizer enabled. Then the only changes you need to do is add this one line of code right here. So you specify compiler config and you specify the training compiler config. That's it. We didn't change the training script. We didn't change anything other than add this one line of code, and we'll take a look at the performance benefits you will get. So I can also initiate the training for this one, and we can go back to the SageMaker console and take a look, refresh this page quickly, and take a look that we now have two training jobs in process. Okay, two training jobs in process. The first one is the compiled one here, and the other one is the native. Okay, so one compiled, one without compilations. We can initiate multiple trainings. Now we will go back, and at the dashboard you can also see that we have two training jobs currently in progress. Okay, go back to the Jupyter notebook, and you can wait for this training to complete, which is what you would do, but thankfully I've run this job before, so rather than wait, this will take an hour or two based on the number of epochs. This should take roughly more than 1 hour. So I won't let you make you wait. What I've done instead is run this job already. So what we'll do is attach to a job that was already run and analyze the result. Okay, the way to attach to a previously run job is to use the Hugging Face estimator and use the attach function and specify the job name. Okay, all you have to do is specify the job name, and when you run this, you get access to the estimator, and then you can also take a look at the training logs. And the logs are basically the standard out, what your training script would output into the standard out of the training instance, which looks basically like this. This is your training progress, the epochs, and the reason I want access to this logs is because I want to pick out the evaluation training and evaluation metrics from the logs, and then analyze the throughput and also the training time. Okay, we'll do the same thing with the compiled training job as well. I'll attach to an earlier run training job, and then I'll capture the output. Even at a cursory glance here, training time here is 3700 seconds, okay, with the optimized, and with the unoptimized, training time is around 5251, okay, 5200. All right, so you see 5200 versus 3700. Okay, so you see that we are able to train much quicker. Now let's take a deeper analysis, do a deeper analysis of the training function. I have some helper functions here that can parse through the logs and pick out the relevant statistics. So let's analyze the two different jobs here. In the first job, you see that the runtime is 5200 we saw, and in the second job, runtime is 3700 seconds. Okay, that's about a 40% decrease in training time. We can also generate a plot and take a closer look at this visually, if you like to look at things visually like I do. So this is a total of 40% savings, because you get much higher throughput, much higher samples per second by just enabling the compiler options. Okay. An important thing to note is that when optimizing compiler optimizes your computational graph, it is changing the graph. So it is making some changes to the graph, which means you can expect the output to be slightly different, which is why it's interesting and important to check the loss accuracy. Okay, we see that the loss accuracy is trending similarly, but there are slight variations between the unoptimized and the optimized graph, and it's important to take a look at this. We'll also take an evaluation loss and accuracy, and you see here that there are slight variation in the evaluation loss, 0.38, 0.34, and evaluation accuracy is also up to the second decimal place the same, but there is a variation after that. And this is expected, because when you change the graph, you expect slightly different results, but it will be within some tolerance that is acceptable to you. Okay, so to quickly summarize, with one line of code change, you can quickly and easily improve training performance just by adding training compiler config into your SageMaker estimator function. And at launch, specific models are supported. So if you're working with TensorFlow or PyTorch backends for Hugging Face, a number of tested models, all of these listed here in the documentation. All these are popular natural language processing models that are supported. If you're using one of these, it's a no-brainer. Just use that one compiler flag to get performance improvements. Okay, so that's it. There you have it. That's Amazon SageMaker Training Compiler. If you enjoyed this video, please subscribe to the channel. I'll be posting more videos on some of the newer launches. I also have a launch summary of reInvent linked in the description. Feel free to check it out. Until then, see you in the next one.